everyone, welcome to another interesting session of our DSA course. If you remember, we are in the course of recursion. We are completing the recursion chapter right now. And today we are here with an interesting topic, that is rope cutting problem. Mostly you can find this concept or this problem asked in questions in interviews. So let's see what's the catch in solving this problem, in solving this concept. So let's move here. So what is the problem statement? The problem statement is we have been given a rope of length n meters and the rope can be cut in only three sizes. So you have been given a rope of a particular length, that is of n meters, and you have been assigned the task that the rope can be cut only in three sizes, that is size A, size B and size C. Your task is to maximize the number of cuts in the rope. If there is no possibility of making a cut in the rope, then you should print -1. Got your question properly? So now let's see the examples. You have been given an input n is equal to 17, that is the length of the rope. The sizes are A is equal to 10, B is equal to 11 and C is equal to 3. So what happens is you have to cut the rope in such a way that maximum cut can be obtained and your output should display the maximum cut. So let's have a look at the explanation. Here the maximum cut can be obtained after making two cut of length 3 and one cut of length 11. So what will you do? You will take length 11 first. You will cut the rope, the 17 length rope into 11. Then the remaining is 6. Then you need to cut it into equal parts. It is 3 and 3. 3 meters and 3 meters. So 3 centimeters and 3 centimeters. You got the output as 3 because you cut it 3 times. Another example. You have input as n equal to 10. The length A is given as 9, B is given as 7 and C is given as 11. So what do you do? So here you are not able to cut the rope into a number of parts. That's why your output will be -1. Now let's do a quick coding part, coding challenge, and let's see how does this solve the problem. So we have been given the problem. Now let's try to figure out the code. So guys, take a minute and try to write down the code on your own. Then we can come back and you can see my code and you can match it up. Your time complexity is big O of 3 to the power n, and auxiliary space is big O of n because of the recursive call stack, because we are using the recursion here. So what we are going to do is, you guys take a break, write down the code and come back and see the video. So for now, just pause this video for a while. Okay, so I hope you guys are done. Now let's see what I have to tell you, like how do I solve this code. Now let's first create a new file, calling it this. Okay, rope cutting created. Now let's write. First I need to declare the function as we do. Max cuts. We have given a length n and the sizes are mentioned. Okay. Then if n is double equal to 0, we can return 0, because if the rope is of no length, we did not cut it. If n is less than equal to -1, we need to return, because there is no rope of length -1, right? Now let's write the recursion. That is the gist of this function. Variable result or resulted, calling the function max cuts, taking the parameters as n minus a, comma b, c. Then we need to take, this is a recursion we have called. Then we have to take the maximum of the max cuts from, again recursion we are calling, of n minus b, a, b and c. Along with, we are taking the maximum of two components. See, you can use the maximum function only for two components, right? Only for two parameters. So what are we going to do? We are going to do maximum of B and C. Suppose you got B, then we are going to take the maximum of A and B, then you get the answer. So this is what we are going to do. We are going to take two maximum functions like the nested maximum functions, and we are going to find out the maximum value. Then max cuts again, the third parameter. Let's take the parameters as n minus c, because n minus a and n minus b are done. A, B, C. Let's check if the resultant is equal to, or the result is equal to minus 1. You return simply minus 1, because there is no rope length of minus 1. Or else what do? You need to return. Then let's write our driver code. Main function name is double equal to, then we are taking the inputs now. N is equal to 5, A is equal to 2, B is equal to 1, and C is equal to 5. What we're supposed to do? Now let's print the max cuts again, calling the function, taking the input as NA. We're done. Now let's run it. So after running, we got the output as 5. So I hope this program is clear to you. You understood how this program worked. You understood the rope cutting problem, which is one of the most important problems of recursion. And now you know what's nested max. How do we use the nested max in our functions? How do we find out the maximum of 3 values? And you know now that maximum function can take the max of 2 values only. So you know how to clubbing these things together. So I hope this was a successful session, and I'll wrap it up with this. Let's not lengthen the video longer. So till then, till I come up with the next video, keep learning, keep practicing, and happy coding.